Good day, grade 8s. This is Miss George speaking again, and today we're going to be doing algebraic expressions, but our lesson is going to focus on simplifying algebraic expressions. Okay, now in order to do that, we need to be able to identify what our like terms are, right? So I'm going to have a few laws here, two actually, that says in order for two terms to be alike, they must have the same variable and the same exponent. So let me write that down. Like terms must have the same variable and exponent. Great. Now what does that mean? Let's look at an example. So if you have 2x and 3x, that is known as like terms because you have an x and an x, therefore the same variable. Each of them has exponent of invisible 1, therefore they have the same exponent, therefore making these two terms like terms. Now, when you identify your like terms, you then can now add and subtract the coefficients from one another. Okay, and you all remember what coefficients are, right? Coefficients is the number in front of the variable. Now if I have these two terms, so let's say I have, example, the expression is 2x plus 3x, okay, sorry, put an x there. So if I have 2x plus 3x, they are like terms because they both have the same variable x and the exponent 1. So once I have that sorted, my variable stays the same and my exponent, the only thing that will change is my coefficient. Okay, so I'm going to add the coefficients with one another. So 2 plus 3 gives me positive 5, therefore leaving me with an answer of 5x. Great. Let's look at another one quickly. Let's just move this page down a bit. Okay, let's look at another example. So if I have 2x plus 3x to the power of 2 plus x plus 5x to the power of 2. Let's look at this. Over here, my variable is x, my exponent is 1. If I look at my second term, my variable is x, but my exponent is 2. So therefore these two terms cannot be like terms. Let's move on to the next term. Here my variable is x, my exponent is 1, therefore it is alike with 2x. Right, moving on. Over here I have 5x to the power of 2. My variable is x, my exponent is 2, therefore making these two terms like terms. So let's just identify them. The little circle around each of them. Okay. So now I can start adding or subtracting depending on the signs that is in front of the terms. Can then simplify my expression. So I have 2x plus x. Remember I said your variable and your exponent will stay the same, so I have x to the power of 1 here, and then 2 plus my invisible 1 that's over there gives me 3x. Right, perfect. Let's move on. So I have 3x to the power of 2 plus 5x to the power of 2. So because I'm adding, it's two positive signs, and now I'm going to end up with a greater positive value. My x2 must remain the same, and 3 plus 5 gives me 8. Great stuff. So there we have it. There we simplified our expression. So now again, I just want to clarify something to you. What you can do is you can always rule a line to identify your like terms, or put a little circle around it, even a triangle, just to make it a bit easier for you, okay, to separate them from one another. Right, so I'm going to give you 5 sums, and then you are going to try to do them all on your own. So here are your 5 questions. Try to do them on your own, and then you can press play again and we can do the sums together. Great. So let's look at this now. Okay, let's look at number 1. I have 5a plus 3a. Are these two terms like terms? Yes, because they have the same variable, which is a, same exponent, which is 1. Right, so now I can add my coefficients together, which gives me positive 8a. Perfect. Let's move on to the next one. Question 2. I have 6x minus 4x. Okay, variables the same, exponents are the same, so therefore I can add my coefficient with one another. So 6 minus 4 gives me 2. My variable is x, so therefore 2x. Now let's look at number 3. So number 3 is a bit longer. So over here we have x, 3x to the power of 2, as you can see. So we need to look for another term that has x to the power of 2. And as you can see, it will be 5x to the power of 2. So because those two terms are like terms, I can now write my variable and exponent down and then add my coefficient. So 3 plus 5 gives me 8. Great. Let's look at the next one. I have x with exponent 1 over there. So I need to look at a term that also has the variable x and exponent 1. Let's just circle this one over here. So that will be this term over here. Okay, so I have a coefficient of negative 1 and a coefficient of positive 3. Okay, so I have 3 minus 1, which gives me positive 2x, because my variable would remain the same as well as my exponent. Okay, the last term I have here is positive 3. Now positive 3 is known as a constant because there is no other constant within this expression. It just remains a positive 3. And there we go. There we simplify that expression. Let's look at number 4. So I have 2x and the other term with an x in it is 3x. So now I can add my coefficient and that gives me 5x. There's no other constant there, therefore I just have positive 8 left. And there's my final answer. Now for number 5, let's do it over here. I have 5x to the power of 2. The next term with variable x and exponent 2 is 7x to the power of 2. So now I can add my coefficients. 5 plus 7 gives me 12. X to the power of 2. Next I have negative 3x and I have negative 4x. Okay, a negative and a negative will give me a greater negative value. So therefore I know the negative sign wins. I write my negative sign down, and 3 plus 4 gives me 7. And what's left is my variable x. 9 is the only constant over here, so again I would just write the 9 down, and there we go. Perfect. See you next time. Bye.